You're listening to the Australian Water Association podcast series. My name is Jo Taranto, and joining me is Jurgen Thiele, the business unit leader at Calibre Professional Services, and we're discussing pathways to a carbon neutral water industry. Welcome, Jurgen.
Thank you for the opportunity.
What's the challenge as you see it for carbon neutrality in our industry?
There is a resilience to change because things have been done a certain way in the recent past, and the urgency is not often as clear as to some of the scientists who have done the climate modeling. And so getting that sense of urgency into the industry is one hurdle that we should address quickly because 2030 is around the corner. But otherwise, there is nothing else that I would know that would actually prevent us from implementing what we have presented here at the conference.
So the tools are there, technology's emerging. Can you tell us about your experience with what New Zealand have done and are doing in this space?
It was actually a council in New Zealand that was leading the way. So the Palmerston North City Council approached us as designers and implementers of biogas solutions in 2008 for a solution that allowed them to produce fourfold biogas production from what they historically had done in their plant to satisfy the requirements of a new generator they wanted to set up to produce renewable electricity. The problem is that the capital that was available was only a fraction of what a new digester facility would cost, and therefore the challenge was to make the existing plant perform fourfold as efficient as it was designed for at minimum added cost. And within that constraint, we then went on with what we knew and achieved within 2 years that target.
And was that using new technology?
It is technology that using existing equipment in a new arrangement, and therefore it becomes a new technology, but a simple innovation. Nothing that requires new engineering, it just requires new use of existing engineering.
So is there, a cost benefit then in the fact?
Very much so. The cost benefit typically of doing it the new way is that it costs only a third of what the cost of providing digester capacity would cost the previous engineering way. So what I'm referring to is I'm a biotechnologist, and we're using biotechnology know-how to make the bacteria in these anaerobic digesters perform more efficiently and more robustly, and therefore you can load and challenge them with more waste than you traditionally could do. And at the same time, these more resilient, robust bacteria are also concentrated up. So you have, if you want so in a military analogy, you have an army that is 3 times the size. So it's much easier to win. Tell
me about what we really know about greenhouse gas emissions in the water industry. Do we know enough about our impact?
I think there are patterns that are consistent throughout councils and countries in the Southern Hemisphere that are recurrent, that we understand, but each side will have its own unique twists that need to be understood as well. But one main source of greenhouse gas emissions is the biological decomposition that happens when the biosolids that are usually produced in a municipal wastewater treatment plant are inefficiently managed. So, for example, putting biosolids in an undigested state into a landfill creates landfill gas emissions that would not occur had they been previously digested before the residue goes to landfill.
So we're not just talking about the power used to run these plants, we're talking about the
Yes,
products that are
yes,
coming out as well.
Yes.
So therefore the role of anaerobic digestion in creating a truly circular economy in this space is something that you're quite excited about.
Very much so. We have demonstrated it in a recent webinar I gave on that topic about 3 weeks ago as part of the Bioenergy Association series of webinars, and yesterday here at the conference. Anaerobic digestion is one of the 3 pillars of a circular economy energy system. And because it is very accepting of a wide range of different feedstocks, it makes it so cost effective to use one common tool to process a wide range of organic waste feedstock and wastewaters.
And what are the other pillars there for the circular economy?
Well, obviously there is solar and there's hydro and there's geothermal, which are very important to utilize, but you're limited there by cost as well as availability. And then there is solid biomass, trees, purpose-grown energy crops for that purpose. And in Europe, the German example is quite fascinating. They also produced since 1990 energy crops that go only into biogas plants to produce fertilizer in the process that can be returned into agriculture to boost food production. And in the process of harnessing solar energy with these crops, they produce extra biogas they can purify and then use in their natural gas grid as green methane or as vehicle fuel. So therefore there are many different ways you can play with these instruments that anaerobic digestion offers.
So Jurgen, tell me about the Aussie innovation that's helping with anaerobic digestion.
Well, it is a very interesting aspect of it. In 2000, our company was involved to design and build the first food waste digester in Australia, in Sydney, the Earth Power plant. And the constraint there was to produce as much gas as possible with as small a digester as possible because of the cost aspects. And so we produced the first recuperative thickening system that thickens up the anaerobic bacteria from the digester, taking them in more concentrated form back into the digester, and by this achieving a higher capacity of an existing digester system.
And are there applications for this then at all future facilities, or is this really a fairly niche use?
Not at all. Sydney Water in 2008 started to use it in some of their plants, and I believe now has a large number, 5 or 6 digester plants already fitted out. We know that in South Australia it is implemented. We know that in Victoria it is implemented at a number of plants. And in New Zealand there are already 2 examples operating, and many other councils will look at that as soon as they have the requirement to increase the digester capacity, because it's so much more cost effective than building. It's also the space on a treatment plant is limited. This is taking up 1/10 of the footprint what a new digester tank would take up.
So moving towards different approaches to wastewater treatment, what kind of investment and payback periods are some of the councils or utilities looking at when they're applying this sort of technology?
It is actually a regional diversified answer I have to give you, because a large income stream for this kind of operation is called the gate fee, which companies will have to pay to deliver their waste to a wastewater treatment plant, which is regionally differentiated. As a typical example, in the Palmerston North case in New Zealand, we were possible to offer a very low gate fee, which made it very attractive at $30 roughly per meter cube of waste. It would be a payback period of 3 to 4 years when the council would have recovered all the initial outlay, but then it would operate for another 10, 15 years, obviously, generating a very substantial profit for the owners.
If we are moving towards this sort of technology and real commitment, as New Zealand have shown, towards greenhouse gas emissions, what kind of reduction do you think is feasible for the water industry?
It depends, of course, on the will. Assuming the will is there, zero emission could be achieved within a decade.
Is that what you'd like to see?
Absolutely, because it is so easy. It would be a shame not to do that.
We've been talking to Jurgen Thiele, who is the business unit leader at Calibre Professional Services. Thanks so much for your time.
Well, thank you for the opportunity.